All right, so how did the homework go? Eventually get it figured out? Okay, so let's kind of go through and look at this. One confusion that a lot of folks had, remember last time we wrote this display card function, and all this guy did is he would take in a card as we defined them, and we decided we would define cards as two-element lists, right? A suit and a display value, I think we called it. Okay, so when we called display card, this guy would take in a single list, a single card object by our standards, and we would print out the creation of a string with the, this would be like 4 of clubs, something like that. Okay, so that's what this function does. Allows us to display a single card. Here's a variable called display values. Display values is a list of all the different display values for our deck of cards. 2 through 10, Jack, Queen, King, Ace. Then we have another list that has all of our suits, diamonds, hearts, clubs, spades in it. Okay? And we're going to use these two lists together to create our 52 cards. Now, in class last time, we went through, and for every suit name, we went through all the display values. And we created, this would, so for each suit name, we have diamonds, then hearts, then clubs, then spades. So the first time through, suit name would be diamonds. This inner loop is going to go through all of our display values. So we would create the 2 of diamonds, the 3 of diamonds, the 4 of diamonds, the queen of diamonds, the king of diamonds, the ace of diamonds. Then this inner loop would end. We'd spin back up, we'd get our next suit name. Now we're at hearts. Go into the inner loop again, we'll get 2 of hearts, 3 of hearts, 4 of hearts, 5 of hearts, king of hearts, ace of hearts. Spin back up, now it's clubs, get all the clubs. Spin back up, now it's spades, get all the spades. But right now we're displaying all those guys. What we really want to do is we want to load them into a list. Because just like we're representing cards as a 2-element list for display value and suit, we want to represent a deck of cards as a list of 52 lists. 52 card objects as we're referring to them. Okay? Again, we're kind of trying to play within the matrix here because directly Blockly doesn't support objects. So we're having to represent our guys as lists with certain values in them. In this case, we want a list of cards. We've already decided that cards is a 2-element list. So I need a list containing 52 lists is what I'm going to build here. Just so happens we have 52 lists. And what are we doing right now? We're just calling display card with them. We don't want to do that anymore. Now what we want to do is we want to add them to a list that we're building. So we're going to start off and create a new variable. I'm going to do this before our loop starts. And we're going to call this guy the deck. Okay, this is going to be our deck of cards. And this guy is going to be equal to, initially, an empty list. There are no cards in our deck of cards. Make sense? Now, we're going to go through this whole thing here, but instead of printing each of our elements, we want to add an element to our list. So we need to look at lists. Okay. We have this thing where we can set an element, in this case the deck. We want to insert something at a certain position in our deck. And what we're going to do is we're going to say insert at the end of our deck. You could have kept track of a counter and stuff like that if you wanted to and say insert at bucket 0, then at bucket 1, then at bucket 2, then at bucket 3. But what do we want to do? Our deck starts off as an empty list. And what do I want to do? The first card I create, put it at the end of that list. What do I want to do with the second one? Put it at the end of that list. Put it at the end of that list 52 times. Okay? So I'm going to go through my list, and each time through, I'll put at the end of my list my card. So this is going to be a list containing a list, well, containing 52 lists. But these lists we're calling cards. This list we're calling a deck. It's a collection of 52 cards. All right, so after this loop is done, we should now be able to loop through our deck and prove that we got all the cards. Make sense? All right, so we're going to go ahead and create another loop. And we're going to say for each, we're going to call this card in the deck. Now, you didn't actually have to do this part for your homework. This part we're doing right now is just proving that this part worked. Okay? We're proving to ourselves that we did, in fact, fill our deck list up with 52 cards. So for each card in the deck, what do we want to do? We want to call display card with oh, the guy already takes a card in, so we just have to pass a card with this guy. So what card am I displaying? The current card from our deck. Now, if I run this right now, it's going to go through 52 times, okay? Which I suppose is an okay problem to have. Let me just copy the XML in case I get upset. All right, so we'll go ahead and run this. So there's my 2 of diamonds, 3 of diamonds, 4, 5. Now I'm at the 2 of hearts, Jack of hearts, Queen, King, Ace, 2 of clubs, 2 of spades, Jack of spades, Queen of spades, King of spades, Ace of spades. That's all of them. Proving that we were able to fill the deck up. Make sense? All right. So that was the homework. Like I said, this part wasn't required, but you probably wanted to do this to make sure that you got the homework right. But I'm not going to look at this. I'm going to be looking at, did you modify the for loop we wrote last time? So really the only thing you had to do for your homework was this one line right here. Right? Might have been a little bit of a tricky line, but that's the only line for your homework. Now, those of you who are asking a lot of questions about the difference between printing and adding stuff to the list, does that make more sense now? There's at least 5 or 6 of you were struggling with, I had people ask, well, doesn't the program already do what it was supposed to do? Because the output to the screen was we had it printing to the screen last time, the exact same thing it's printing to the screen now. But the means by which we're getting that information is different. Now we're putting it in a variable called the deck. We're putting it into that variable so that we have access to it later. Now, what things might we want to do with the deck of cards? You go up to Potawatomi and you saddle up to the blackjack table. What are they going to do there before they start playing? They're going to shuffle the deck of cards. What does it mean to shuffle a deck of cards? Well, I guess in effect, if you want to treat a shuffled deck, if you want to avoid shuffling the deck and always just give you a card from the deck at random, in our case here, we wouldn't actually have to shuffle it. We could just say pick a random spot. I think doesn't list allow us to do that? In list get. Just let us do a random one. Yeah, just give me a random card from the deck.
Would you be able to get the same card twice though? If you're
potentially, we'd have to remove it. We'd have to remove it. So, if we want to do this, so this will get us 52 random cards, and let's just see. I don't think this removes it from the deck. I think it'll still stay in the deck.
You need to change the list to the deck.
Oh, thank you. There we go. I thought I just copied. Didn't I just use this line? Oh, no, this is the new one I brought out. All right, so there's our Ace of Hearts, 2 of Spades, 4 of Clubs, 9 of Clubs, Ace of Diamonds, All right, so this allows us to get a fairly random card. But what we want to do is we actually want to write our own ability to shuffle the deck. Make sense? That way, our deck is in fact like a deck looks like in real life, where if you flip through it, they're always dealing off the top of the deck, correct? So it needs to be random from that perspective, not just random stuff in the deck. Now, do you know if I keep pressing enter after the last one, will it accidentally hit the plus button again?
Mm-hmm.
It will?
Yeah.
Oh my gosh. I can't even count up.
You just click OK and then be a little safer.
Yeah, but that's not fun. Why didn't somebody warn me? All right. Nailed it. Let's copy this again. I don't remember if that's the current state I had. Okay, so we need to go up here. We'll do it up here at the top. And we're going to write a function to shuffle our deck. So I'm going to create a function. We're going to call this guy shuffle deck. And this guy will take a input D, which is our deck, and we're going to shuffle it. Now we know that D is a list of cards, which in this case is a list of lists. Okay? How would you suggest that I shuffle the deck of cards? That's your smirk for. Yes. Huh? Do I have phrasing? Always have to be concerned with that with programming, that we don't have like a weird variable or function name that means something very different that I missed. That happens sometimes. Okay, so I don't have that. You're just thinking about something that's... I get it. Go ahead.
In either logic or math, you could pick, like it was kind of before, where you choose random, because that isn't that what shuffling is?
Well, yeah, I mean, in real life, we think of, we kind of cut the deck in half and then kind of do the thing, and then you have the people who can do the really cool ones, right? Like, you do the normal thing, then you bridge it, right?
Yeah.
What's the point of the bridging?
Just to show off.
Isn't it? And you got the guys like... That's the whole purpose. That's how magicians do the card tricks, is they like palm cards, so they always know what card's on the top. It's just infuriating. Yeah, I can't even do the normal. I can, but not very well. You end up like it just goes in 3 or 4 chunks. It's like, there we go. Want to cut that? I also only play Go Fish, so it's my go-to game. I don't know why this came up in my head, but so my wife is like terrible at like all board games and card games. She's not good at any of that except Chinese checkers. She's like a savant. It's ridiculous. I've seen her. I mean, first of all, who plays Chinese checkers, right? Nobody plays that. Okay. In fact, for all we know, it might not even be like a real game. It might become like something that somebody made up as like an anti-Chinese thing or something. But yeah, she's like awesome at it. I don't even know the rules of the game, but she teaches them to me, and then it's not like she practices. She plays once a decade or something. Yeah.
Instead of creating a new function, couldn't you
We're talking about Chinese checkers. Where are you coming from? Get with the program. Go ahead.
Instead of creating a new function, couldn't you just set where you set item in deck set where it lasts? Couldn't you just set that to random when you're loading it into the deck?
You could, but then basically you only have a shuffled deck once. Where if we think about a deck in real life, after you play cards, you want to be able to reshuffle it, right? But you're right. We could kind of build it randomly. I think that would be reasonable enough. Yeah.
Loop it?
But we'll definitely got the loop. So what I'm going to suggest is, because we're trying to mimic that idea of, you know what I mean. We're trying to mimic the people who are like listening to the audio. They know what I mean too. So, because we have several students who just watch this online. In any case, we want to kind of mimic that. So, could we just randomly pick 2 places in our deck and then just swap those, and then do that like 1,000 times? Is that likely going to jumble stuff up pretty well? Okay. Well, so let's start off by selecting at random 1 card in our deck. Okay. Before we can select 2, we need to be able to select 1. Then we're going to try to swap those 2 and prove that worked. Okay. Then we're going to do it 1,000 times. Again, little baby steps. And we're not using a loop in this one. We're going to literally write it 1,000 times. That would be some crazy looking XML. Okay, so let's start off. We're going to look at our lists. So we're going to get a random card. That's actually going to be a little dangerous. We don't want a random card. We want a card at a random position. So let's start off by generating a random position between 1 and the length of our cards. So in this case, it's 52. Okay? So we're going to start off by, let's just print that initially. So we're going to print something. We'll print out a random integer from 1 to length of our list. Did we determine that this is inclusive? There, we can do this real quick, just so we know we're legit. I'm going to put a 4 in here, so we know we're random. We know it goes all the way up to 4 if we at least get a 4. Shouldn't take us that many tries to get a 4. So if we do this 10 or 12 times and we don't get a 4, we're in trouble. So let's just loop this real quick. So let's repeat this 10 times. What are we going to do 10 times? We're going to print out 10 numbers. And we're going to decide that this is in fact definitive. If we run this 10 times and we never get a 4, that means that 4 never comes up and we actually need to go all the way to 5. All right. We're not going to display these guys right now because that was troublesome. We are going to now shuffle our deck, and our deck is called theDeck. I'll just steal this guy and rename it. Okay, and what should Shuffle Deck do right now? Shuffle Deck right now just does 10 things. It prints out 10 times some random number between 1 and 4. We know we'll get a 1. I'm hoping we get some 4s, and then we know we're good. That means that we'll be able to go and get a random number between 1 and 52, including 52. We're good. I have a bad habit of just acing things the first time, and it's because of I write the code. Let's see if we ever get another 4. There we go. Okay. I think we're legit. Okay. So now instead of it being 4, we're going to go to the length of our list, which was called theDeck. So we're going to get a random number between 1 and 10, or 1 and 52. Let's just do 3 of these real quick, just to make sure we're getting a decent range. There's 2, 45, 15. Fair enough. All right, we need to get 2 of those. But what we actually want is we want a card at that position. Okay, so instead of printing this guy, we want to display a card, because we wrote the function to display a card. And what card do we want to display? We want to display the card at this position in the deck. So we're going to use our list. We're going to get from the deck something at a certain bucket. What bucket? A random number between 1 and 52. So this is going to get us some card, and we're going to print that card. This will do it 3 times. Okay, just proving we can extract random cards from our deck. 2 of clubs, queen of hearts, 2 of clubs. What are the chances of that? Now what I'm going to do is I'm going to actually give you 3 king of hearts in a row. testing fate here, right? All right, so we're getting random crap. We're good. All right, so now what we want to do is, now that we have our position, that's this guy. This is our position, right? We want to figure out what are the 2 positions. We're going to generate 2 positions, and then we want to swap those guys in our deck. Make sense? So if I generate position 3 and position 9, just the numbers, not the cards there. We just proved that we were accessing real cards. So I got the number 2, I have the number 9. Now I'm going to say I want the card at bucket 2 to actually be the card at bucket 9, and the card at bucket 9 to actually be the card that used to be at bucket 2. Just swapping those 2 places. Okay, and if I do that 1,000 times, won't I have a pretty jumbled up deck? Okay, but notice here, when I did this, when I replaced the card at bucket 2 with the card at bucket 9, I overwrote this guy. So I actually need to preserve this someplace else before I overwrite it. Then I can copy this guy down here. Okay? So all we're doing right now is we're generating 2 random numbers, and we're going to print those out. Just printing the random numbers, proving we have 2 different numbers. So I'll get rid of this. We're going to need a couple of variables. Call this pause 1. Oh, hello. And, oh, that's a new variable. Pause 2. And this guy will be a random number. And this guy will be a random number. All right, and let's just print those real quick. I think we've already pretty much proven that we're good with this, but there's pause 1. And there's pause 2. Now I'll just get rid of this for right now. So we should just get 2 random numbers between 1 and 52 to the screen. There's a 34, and there's a 5. Now what we want to do is we want to swap the card that's at bucket 32 and the card that's at bucket 5 with each other in our deck. So after that one swap, our deck should be a little bit different than it used to be. The card that used to be at position 5 should now actually be at position 32. And the card that used to be at position 32 should be at position 5. In order to do this, we're going to have to preserve one of those positions, preserve the card from one of those positions. So I'm going to need another variable. I need to remember something. Okay, so before I overwrite the card at position pause 1, I'm going to store the card at position pause 1. That way in a few minutes I can overwrite the card at position pause 2 with that card. Okay, so I'm going to create a variable here. We're going to call this temp card. That's going to be our temporary card. And we want to get the card. We can either choose pause 1 or pause 2. It doesn't matter as long as we do the rest of the math right. Let's just do pause 1. So we're going to preserve the card at position pause 1 in our list. So we're going to say from our list, get, so from the deck, get the value at position pause 1. All right, this doesn't remove it, it just copies it, gets us a pointer to it. All right, so we've preserved that inside of temp card. Okay, now we're going to overwrite position pause 1 in our list with whatever was at pause 2. So we're going to say our list the deck. Yeah, this should be fine. We're going to set position pause 1 equal to in list the deck get position pause 2. Okay, so we'll set whatever was at pause 1 with whatever is at pause 2. Then we'll set whatever's at pause 2 with temp card. Okay, and we want to go ahead and print those cards. So we're going to display, we're actually going to do 4 displays. We want to display position pause 1 and pause 2 before we swap, and display position pause 1 and pause 2 after we swap, proving that the swap worked out okay. Okay? So we're going to go ahead and we're going to call upon our display card. We'll do it before the swap. And this guy is going to take get the guy at pause 1. Then we'll get the guy at pause 2. And then after this, we'll print them again. Pause 1 and pause 2. And then finally, let's print out the length of our list to make sure setting things at certain values didn't actually like lengthen our list to 54 in this case or something. So we'll go ahead and print the length of the deck, which should still be 52. All right, so what should display here? We should get 2 random numbers, and then we're going to display the card at position pause 1 and the card at position pause 2. Then we're going to do our swap, and then we're going to display the card at position pause 1, which should be the same as the last card we just saw. And then we're going to display the card at position pause 1, which should be the same as the first card we saw, proving they were swapped. Okay? So we have 4 hearts. 5 of clubs, so the next one we should see is 5 of clubs. 5 of clubs, and then we should see 4 of hearts. 4 of hearts. And this should still be 52. 52. All right, so we've accurately swapped cards and proven that our list is not bigger than it was before. So we can get our display cards out of here now and get rid of our print length. And then we want to do this 1,000 times. Well, we have a loop. Put this loop in here. We're going to say let's do this 1,000 times. And we're going to do all that 1,000 times. Make sure you've removed your prints. Or it's going to be a long day. And make sure you copy your XML. Or it'll be a depressing day. All right. So that's shuffle deck. Well, whatever. It's up there. Here's our loose functions here. So we're going to call shuffle deck. And then let's go ahead and let's just, well, let's just print the values for our deck. you know, just to keep us sane, I'm going to create another function real quick. We're going to call this guy displayDeck. And displayDeck is going to take a single parameter, D. And this guy, what we're going to do is we're going to build up a string. We're going to build a string that is the contents of our deck. Actually, can't we just print a deck and it'll just show up okay? Yeah. It'll at least be good enough for us to tell it worked. Yeah, so we don't even need to do displayDeck. All right, so after we shuffle the deck, we're just going to print out the deck, and it should not be in order anymore. And if it is, that's another sign of the apocalypse. So that means somehow we swapped 1,000 things and ended up with the original deck. All right, so hit play. 3 of spades, 10 of clubs, jack of diamonds. Seems pretty jumbled up. Okay. All right, so now we have a deck. Well, now we need to have a, good.
What would happen if both of them chose from the same position?
We would swap in the same position. So
It wouldn't
we would
work
replace
out.
2 with 2.
Okay.
I mean, just think about how this works. So let's say we just had bucket 2. We would preserve the value of bucket 2,
Okay.
take 2 and copy over 2, then copy over 2 with 2.
Okay.
So kind of wasted our time, but not the end of the world.
Yeah.
We didn't break our deck of cards. Okay, so now we need to be able to have a well, we want to start playing games with this, right? So how many of you have played the game of War? How does the game of War work? I haven't actually played it. I only played Go Fish. So Wars, you have the well, we split the deck in half, right? So each person, each player gets half the deck. And they don't get to look at it. They just feed the card off the top of the deck. And that competes against the other person, right? And whoever has the higher card wins. What if they're tied?
And you flip another one over.
If they're tied, then whatever boiling hot pocket you have in front of you, throw at your opponent. Okay, so if they're tied, what do you do? Is it like 3 cards?
Yeah.
Put 3 cards down,
And then the 4th one is like a new turn, right? It's okay. So then each person also has a score, correct? So when we have our players, like when you win, you get a point, correct? So there's 52 points you can possibly win. So, well, actually, no,
Just
there's.
once you got all the cards you want.
Oh, is that it?
Yeah.
Whoever has more cards?
Yeah.
Whoever has the most cards. So isn't that kind of like points?
Yeah. So you could keep.
So you could
counting.
potentially have the entire 52 cards.
Yeah.
Or you can just add things like, you know, have your cards. So let's do that. That kind of makes the most sense, I think, right? Okay, so what's a person? Well, a person is going to initially we need to be able to build a person, build a player. So we have 2 players here. All right, so we're going to go ahead and create a function. This guy is going to be called build player. And we're going to give a player a name. Okay. And this guy is also, here, I actually stole the wrong one. I want the one that returns something. So build player is going to take in the player's name. Okay, and we're going to go ahead and create a list because we're kind of representing all of our objects in this language as lists. So cards are 2-element lists, right? Display name and suit. Then a deck is a 52-element list containing a whole bunch of 2 lists. Now a player is going to be a name and a empty list for the cards that they've won, correct? And then another list, which is going to be their half of the deck. So we're going to be dealing cards, right? So we're going to deal cards to them, and each one of them should get half the deck of cards. Now, is that how it works in Word? Do you just cut it in half and give it to them, or you actually just deal 1, 1, 1, 1, 1, 1, 1 like that? It seems to be the way it should work. I mean, I'm sure when they have the gambling table at Potawatomi for war, why don't they have that?
How would they make money off of that?
How do they make money off of roulette? Isn't that just random luck too?
Well, yeah, but with war, you're saying you'd be playing against one dealer?
Yeah.
That'd be a waste because then you're only getting one customer at a time per employee.
This will make the buy-in something ridiculous.
I guess.
I never understood roulette though. Like you just pick the color?
Or number or...
Yeah, I mean, what's the point? I mean, there's like no strategy to it.
Yeah, true.
You know, at least like with the, like
blackjack, you can count cards.
Well, or whatever, or even trying to read your opponent, or at least you're taking a strategy of, okay, I'm at 17. Should I stay? At least there's something about it.
Mm-hmm.
Poker, you're looking at the current card you have, and you're trying to decide whether or not it's likely that your opponent has something better. And you're trying to read their mannerisms and stuff like that, and you decide, should I bet or fold, whatever, that kind of stuff. I mean, so at least there's a little strategy. I don't gamble, so I mean, I'm sure it goes even deeper than that because I always lose at those things. I can't even win at Chinese checkers. But the punchline is that, I mean, roulette doesn't even make sense. Like, let's take all our cash and go over and bet on red or white.
You can see that with like a lot of things, like slots. You're just pulling a lever down.
Oh my gosh, seriously! I was a big winner in slots in Vegas.
And you're hating on roulette.
No, yeah,
It's
get
the
this.
same thing. You're just sitting at a thing.
No, hold on. I have an excuse though. My wife went shopping.
Okay.
So I followed her shopping. I don't go into the store. She's looking at purses and crap. So in Las Vegas, even the malls have slot machines. I was playing the nickel machines. I won like $250 in the hallway on a nickel machine.
But that's the same thing. You see, it didn't take any strategy or skill for that.
I know. It just burned time because she was in there shopping for purses.
So maybe that's what roulette is.
Why does she circle the rack 30 times looking at the same purses?
I don't know.
I don't understand. Oh, you want to hear something funny? This was really funny from the fishing thing this weekend. So I'm a beginning fisherman, so I decided the way to start fishing was to fish in a bass tournament with professional fishermen. Totally true. Some of these guys had like boats with their names on it and were like sponsored by Lowe's and stuff like that. And I just get assigned to a random person's boat to like sit in the back and try not to screw up. It was kind of fun. I was pretty happy I didn't embarrass myself or fall off the boat because I was in charge of netting his fish. So this guy in the front of the boat that, like wins money fishing in fishing tournaments, he's reliant on me, Joe computer professor. This is his first time on a bass boat to net his fish. So I did all right. But what was funny is I was talking to the guy about the different equipment and, like what's considered to be like a good fishing rod. Who in here fishes? Okay. How much would you say that like a good quality fishing setup for like a bait caster should cost?
300.
Yeah, who said that? Okay, so you know what you're doing, right? Yeah, so he's like, oh yeah, I don't get the starting point for a good reel is $175, and I won't buy anything over a $100 rod because they break too easily. And the guy's got 25 rods on the deck. I brought 2 rods in case one of them, really, I say in case one of them broke. Really, I meant in case I stepped on one of them. Okay, so in this guy, he's got these rods lined up with 30 different kinds of line and all sorts of different lures. I mean, I'm like, I would definitely step on that. Actually, getting off the boat, I fell. Almost fell on all of his rods. That would have sucked. Okay, but the funny thing is, so he's telling me, yeah, about $275, $300 is like what's kind of the starting point for a good rod. So I look down. I have my Cabela's Special. It was a $50 bait caster that was the reel and the rod combined. I still had the price tag on it. And even worse, they zip tie it on there. So, you know, and which was good because I recognized when I was out there after about 7 hours in the lake when I wasn't catching anything that the thing wasn't screwed down. So the only thing holding the reel on this rod was zip ties. And I was fishing in a tournament. And I didn't get last. I finished middle of the pack the first day. The night before, my wife yelled at me. I was trying to, one of the guys told me I was supposed to have monofilament on one of my bait casters, a different kind of line. I only had braid on there, and the guy at Cabela's did it for me. So I decided, oh, I can do this. There's YouTube videos for putting line on a reel. 2.5 hours later, I got my wife out there. We're watching this YouTube video on how to tie the knot to get the thing to go. And she comes out and she's yelling at me. She's like, "You've been out here forever. I thought you passed out or something." It's like, I don't think you're ready to fish in this tournament because I lost a shoe. while I was putting line on this reel, I lost a shoe. And she didn't understand how that happens. She decided that I shouldn't be fishing at a fishing tournament if I've never caught a fish. And trying to put line on a rod, I lose a shoe. She decided there was a big gap in between. And the thing is, I was wearing Crocs. And the line got caught up in one of it because I just had line everywhere, right? Oh my gosh, one of the times I thought I had the knot good, and then I cut the wrong line. Everything was good. I was trying to trim the knot up, and I cut the 300 yards. It's like the moon's aligned, and I just hit the reset button. Oh, it was terrible. So I showed her, didn't I?
Did you ever find your shoe?
No, I didn't lose. The shoe just came off me.
Okay.
Yeah, the shoe was about 7 feet away from me. Yeah, it was fine, but it was not on my foot anymore. It's kind of the punchline. All right, so let's look at build player here. So for build player, we want to create a list. And we want this list to have the person's name. And we want it to have a list of his winnings, so the cards he's won, right? And we want to have a list that has that's his deck, you know, that he's playing from, okay, his deck of cards. Now, at the beginning of the game, before he's ever been dealt cards, he has nothing in his winnings, and he has nothing in his deck, correct? Both of those things are empty. All the dude has is a name. So what I'm going to do here is we don't even need to have any statements in there. We're just going to have build player, and this guy's going to build a list. And the list is going to be built with the person's name, as well as 2 empty lists. Okay, so maybe we decide that the middle list, so the thing at bucket 1 is their deck that they're playing from, and the thing at bucket 2 is their winnings, like the cards they've collected from winning. Okay, so we'll go ahead and give them 2 lists. All right, so now we can build a player. Okay, and that's going to return our player. So I'll go ahead and do this. So we're going to create a variable. We're going to call this guy player 1. And player 1 is going to be the result of build player. Passing it Mike. And then we'll have player 2. Which will be the result of build player passing it. Who's my opponent? Jonathan, you're my opponent? All right. Going down. All right, so we're building these players. For your homework, we've already shuffled the deck. You should remove the cards from the deck one at a time, handing 1 card to player 1, 1 card to player 2, 1 card to player 1, 1 card to player 2, filling up each of these players' decks, which we decided was that position 2, their second list, or their first list. I think came right after their name in the list. So when all is said and done, each of these guys should have 26 cards. That make sense? I would suggest you print out each of the players' cards just to prove that each guy has 26 cards. So for next assignment for Wednesday, just give them each 26 cards, but those cards should actually be removed from the original deck. Make sense? All right. I'll see everybody on Wednesday.